Today we'll be looking at primary and reciprocal trig ratios. So let's just review first our primary trig ratios. So we have our sine, cosine, and tan. So remember our little key word here. So, katoa. So using SOHCAHTOA, we know that sine is going to be equal to our opposite over hypotenuse. Cosine is going to be equal to our adjacent over hypotenuse, and tangent is going to be equal to our opposite over adjacent. So now in our first example here, what we want to do is we want to look at this triangle below and we want to find x. And we're going to find x in terms of sine x, cos x, and tan x. Okay? We should get the same angle for x, so let's see what happens there. So we know sine x is going to be equal to our opposite over hypotenuse, so it's equal to 6 over 10. We can do the inverse of x here, or of sine, to find out x of 6 over 10. And what we're going to get is x is going to be equal to 37 degrees. So next, cos x is equal to our adjacent over hypotenuse, so 8 over 10. Again, do the inverse of cos, and what we get for x, believe it or not, is 37 degrees. And tan x is going to be our opposite, so 6 over our adjacent, which is 8. Again, do the inverse of tan here, and what we're going to get is, again, 37 degrees. So therefore, we can see that sine x, cos x, and tan x are equal to one another. Or, sorry, x is equal to one another in each of the ratios. So, looking at also talking about trig, we often will use Greek letters. So just to review a couple of Greek letters, we have what we call theta. We also work with alpha. We also work with beta. Sorry, I shouldn't have said equals. And we also work with gamma, just to name a few of the Greek letters. What we'll often use in most cases is theta. So now in example 2, we want to find the side length of x. So this should be review from yesterday's lesson, so if you could pause the video and then come on back and we will discuss it. So, looking at this question here, since we are working with our 60 degrees, and we know therefore that x would be our adjacent and 12 would be our hypotenuse. So we would have cos 60 is equal to x over 12. Bring that 12 up here. So we have 12 times cos 60 would be equal to x. Put that in the calculator, and what we're going to get is that x will be equal to 6. Again, just reviewing our primary trig ratios, we have our sine, our cos, and our tan. Sine is equal to our opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. And the key word, SOHCAHTOA. Okay, always remember this. So now discussing our reciprocal trig ratios. So this is new to you guys. So talking about our cosecant. Cosecant is equal to 1 over sine. Now for short form for cosecant, we have CSC, theta, is equal to 1 over sine theta, we know is equal to opposite over hypotenuse. When we do some algebra there, we get that cosecant theta is equal to our hypotenuse over opposite. So you notice it's actually just the opposite of what our sine is equal to. So let's look at secant. Secant, we have SEC theta, is equal to 1 over cos. Well, we know cos is equal to adjacent over hypotenuse, so therefore secant theta is equal to hypotenuse over adjacent. And then talking about cotangent, short form is COT theta is equal to 1 over tan theta. We know tan theta is equal to opposite over adjacent, so therefore cotangent is equal to adjacent over opposite. So now let's use that for example 3. And let's determine what cosecant, secant, and cotangent are. So we just need to actually do the ratio. We don't actually need to solve for theta here. We'll do that in part B. So cosecant theta. We know cosecant theta from above is equal to our hypotenuse over our opposite. So our hypotenuse side is always opposite our 90 degree. So we have 5 as our opposite, and we have, our hypotenuse, and 3 is our opposite of our theta. So since cosecant theta is equal to hypotenuse over opposite, we know that cosecant theta would be equal to 5 over 3. We know also secant theta is equal to our hypotenuse over adjacent, and 4 is our adjacent side. So secant theta is equal to 5 over 4. And cotangent theta is equal to our adjacent over opposite. So we have our cotangent theta equal to our adjacent 4 over our opposite, which is 3. So now in part B we want to calculate theta to the nearest degree. So we can take any of those equations from above, those ratios. So let's take cosecant theta, which is equal to 5/3. Well, I know cosecant theta is equal to 1 over sine theta, which is equal to 5/3. Now if I do some cross multiplication here, I'd get 3 is equal to 5 sine theta. I can then divide both sides by 5 and continue up here. So we get sine theta is equal to 3/5. So then I put in my calculator the inverse of sine of 3/5, and what I'm going to get for theta is 37 degrees. Now in our last example here, we have triangle ABC is a right triangle. So I'm going to draw my triangle ABC here, and I know that it's a right triangle. So it also has side lengths of 6, 8, and 10. Since I know my hypotenuse is always my largest side, I know that this side here is 10 centimeters. It also tells me if side CB is equal to 6 centimeters and angle C is 90 degrees. So I know this is going to be my angle C, and I'm going to label this as A and B, and it tells me that CB is 6 centimeters. So therefore I know that AC would be 8 centimeters. Which trig ratio of angle A is the greatest? So we're going to look at angle A here. We're going to do our primary trig ratios and our reciprocal trig ratios here. So first, let's label our triangle. So looking at angle A, if we draw our arrow to our 6, that's going to be our opposite side. If we draw our arrow from our 90 degree angle, we know that's our hypotenuse, and side AC is our adjacent side. So now what we can do is we can look at each ratio. So sine A, I know is going to be equal to our opposite over our hypotenuse. So that would be equal to 6 over 10. But I can reduce that, so sine A would be equal to 3/5. Alright, so I'm going to reduce each of them when I put them in the ratios. So next what we can look at is our cos A. Now we know cos is equal to adjacent, so 8, over our hypotenuse, which is 10. So that's going to be equal to 4/5. And then our last trig ratio that we are looking at for primary is tan. So tan A is going to be equal to our opposite, so 6 over our adjacent, which is 8. So that would be equal to 3/4. And now what I can do, since I know my reciprocal trig ratios are just the opposite of the relative primary trig ratios, I can just flip them. So we know that cosecant A is just equal to our 1 over sine A, so we can just flip that, so it's equal to 5/3. We know that secant A, flip our cos A, so it's 5/4. And our cotangent A, flip our tan A, so this will be equal to 4/3. Now the question was asking which trig ratio is the greatest, so therefore cotangent A is the greatest. And this is just looking to compare all of our different ratios and getting familiar with our primary and our reciprocal.